All right, so I'm trying out this problem today called majority element. Given an array nums of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. Okay. So what are the different ways to solve this problem? So majority element basically occurs more than half times. I could obviously do it in O of n time by just going through the array, making a count of the number of each element. And if I find an element whose count is greater than the size of the array by 2, then that's the result. So let's quickly code that one. So that is we're maintaining count. So we use a hash map. Okay. So we get a hash map with a integer map equals to new. So you get your hash map, and then what you do is for each integer num in nums map dot put. What do we put? The num and count. So we might have to increment. So 1 plus map dot cat or default num comma 1, right? Sorry, 0. So it will increment the count, and at any point if map dot cat of num becomes greater than nums dot length by 2, we just return num. And this shouldn't happen, but if it happens, fine. Let's run the code and see if this works. It's accepted. Let's submit and see if that works. And it's accepted here as well. Let's go back to the problem, but it was obviously one solution where it takes linear time, but in terms of space, it takes, because you're using a map, it takes of n space as well. There's a follow-up here, which says, could you solve the problem in linear time and constant space? Now that will be the interesting bit. How can we solve the problem in constant space? So let's take a look at this example 323. So in 323, essentially, let's say I look at it 233, whatever. Or here this 221122. Essentially, there is one occurring 3 times and 2 occurring 4 times. So when there is actually a majority element, what can we do? Is there another algorithm? Is there another approach that we can take that can find a C algorithm without using an extra space per unique key, right? You can have one or two variables, but not a extra space per unique key. So there is this algorithm called, I think it's called Boyer-Moore voting algorithm, something like that, which can find out if given that if there is a majority element, which is what the case here, you may assume that the majority element always exists. So that means in your array, there's definitely one element which occurs more than half the times. Then there is an approach, or there is a solution, there is an algorithm. What this algorithm says is you take a candidate, right? So it doesn't matter in which order your array elements are. So you can take the same order in which we saw it. Let's take this example. So it was 2 2 1 1 1 2 2. Now what this algorithm says is if there is a majority element, you just start with any element as a candidate element. So you maintain two variables. One is candidate, another is count. Okay. Now what you do is you initially take your first guy as the candidate. So okay, so my candidate is 2, my count is 1, right? Or whatever, right? And then you walk through the array, and what you do is this. If the element that you're looking at, it matches with your candidate, then increment the count. If the element that you're looking at does not match with the candidate, decrement the count. And if your count is zero, then whatever element is you're looking at, make that the candidate element. So in this case, if you go walk through it, next element is 2, matches with the candidate, my count becomes 2. Next element is 1, does not match with the candidate, so I will decrement the count. Again, I see a 1, I'll decrement the count. Now when I come here, my count is 0, and so based on the algorithm, the count is 0, then you change your candidate to this guy. So now I change the candidate to 1. The next element, it's 2. Oh, sorry, when I change the candidate, I'll obviously make the count as 1 as well. Now when I look at 2, I'll decrement the count because it does not match the candidate. So it becomes 0. Then I come to 2, and because the count is 0, I make it the candidate. So count 2, candidate 2, count 1. Now, you may argue, what does it really work? So, I mean, obviously you can see this 2, 2 and 1, 1, they cancel each other out, right? So that's completely like you could eliminate, you can just remove this. And now essentially your array just becomes this. Now 1, 2, 2. Now you could have always argued that 1 and 2 will again cancel each other out. And what if this 3 was the case? And would, like in an example like this, 2, 2, 1, 1, 1, 2, 3. The three twos and three ones cancel each other out, and finally you'll just make the candidate as 3, right? And count as 1. You'll say is 3 the majority element, but not, because of this condition. You may assume that the majority element exists, right? Because we are assuming the majority element exists, and at the end, whatever candidate we are left with has to be the majority element. In this case, the input is wrong because it does not have a majority element, because there is no element which occurs more than half the times. All right, so how does that algorithm look like? So basically, like we said, we what's the length of the array? Can the length be empty? No, the length cannot be empty, right? So you assign your candidate to nums of 0 and assign the count as 1. And then what we do is for int I equals to 1, I is less than nums dot length, I plus plus. If uh, your nums of I matches with the candidate, then your count plus plus. Else if count is already 0, then you don't want to decrement, then you just make that guy as a candidate. So candidate equals to nums of I, count equals to 1. Else you decrement the count, and at the end of it, what you are left with has to be the majority element. So let's run the code and see if that works. Okay, candidate. All right, submit this. And it's accepted as well. Let's try this majority element 2 as well. What's this about? Okay, given an array of size n, find all elements that appear more than n by 3 times. Okay, so earlier we were looking at an element that occurs at least half the size, or rather than more than half. Now this is the elements that occur more than 1 by 3, more than n by 3. So first question is, how many such elements can be there? So if an element is of size, an array is of size 6, so for example this, so 2, 2, 3, 3, 4, 4, none of the elements meet this criteria because they have to occur by 3, that means more than 2 times. So let's say I do this, and then I do 2, 2, 2, 3, 3, 3, and 4. So basically I divide the array into 3 parts, right? So this is my one part, this is my another part, this is my another part, right? So obviously, so it has to be all this matches, all of that matches, but this has to be more like this plus plus something from here, right? And then this plus something from here, because more than one budget. So definitely you can only have like so like for example 2222 or other 2222 and then 3333 and then okay, so this is 4 plus 4 8. So 12 by 3 is 4, right? So if I want to have 4, then if I do 4, 4, 4, 4, it just defeats the purpose because it's exactly by 3. So what I can have is maximum is 11 that I can have. And so let's say I can have 4, 4, 4, right? Because so this is the maximum that I can have. In this case, my size array is 11. So 11 by 3 is like 3 point something. So basically more than 3, 4. So I can, by this I can clearly see we can only have two elements that can occur more than one by more than one third of the array. But okay, and obviously again one of the approach like always can be just a map hash map based approach. You just count just keep the count of all the elements and then the elements which occur more than one by three times and by three times return it. So let's quickly write code based on that. So you have your map or integer map equals to new hash map, and then what? So for each int num in nums map dot put num 1 plus map dot get for default num 0, and if at any point if map dot get num is greater than uh, nums dot length by 3, then you have to do what? So let's maintain a list of integer. But we don't want to add it again and again, right? So maybe we can set as well. So and then you do when this happens set dot add and then you return new array list out of this set. How about that? So I don't need this, right? So basically let's quickly see if that works. Okay, submit and see if it works. It's accepted. Now again, if we look at this problem, there is the same follow-up as the previous one. Could you solve the problem in linear time and over one space? So it turns out the Boyer-Moore algorithm, it can be extended to even find two majority elements. Uh, so like in the earlier problem, we took, let's see some examples here. Okay, not good examples, but okay. We'll take this example itself, 2, 2, 2, 2, 3, 3, 3, and 4, 4, 4. And let's distribute them randomly. Obviously, so basically the idea there is you, instead of taking one candidate, so take two candidates or two majority elements, and the same approach applies. So if your candidate, if your number matches with any of the two candidates, then you increment their corresponding counts. If otherwise, if it does not match with any of the two, then decrement both counts. And if any case the count is zero, then if count of any of the one candidate is zero, then you assign that num as that candidate. So, for example, here this is a simple example because you will do candidate one, candidate two. Start with candidate one as two, candidate two as three, and you will keep on incrementing its count, which will become 4, and you will keep on incrementing its count, which will also become 4, and then there will be this 3 4. So these, both of these will get decremented 3 times. This will become 1, this will become 1, and eventually you will be left with 2 and 3 as the answer. Right now let's distribute this 2 and 3 randomly to see if it still works, so for example, let's say 2 4 4, and then again maybe 2, and then 3 3, okay, and then some one more 4, and then 2, and then 3 3, right? I want one more 2 somewhere. Let's put another 2 here, right? Let's say it is distributed like this. Now let's do it. So now our candidate one, I'll call it majority element one, majority element two, and then in the brackets I'll keep the count, right? So I'll start with 2 with count as 1, and majority element 2 will start as 4 with count as 1. Now next guy is 4, so I'll increment the count. Next guy is 2, I'll increment this guy's count. Next guy is 3, does not match with either of them, so decrement the count again 3, so both becomes 0. Then 4, so because it's 4, this becomes 1. Then 2, when it comes to here, I mean, yeah, okay, it's the count is it does not match with this, it matches with this, okay, it just becomes 1. And then 3, again, because 3 comes 0 and 0, you have to remember that this candidate M4 is here, right? And then 2 occurs, so this becomes 1. And now 3 comes. So when 3 comes, you see it does not match either, but count of this guy is 0, so you make 3 as the candidate, right? And so that's how you get 2 and 3 again. So it's an interesting algorithm, but it works. So we can try and try that approach as well and see if it works or not. So you start with what's the minimum length is 1. So we let's do slightly differently. So instead of 0 and 1, we can take like majority element 1 as some random small value, and maybe do the same for M2 as well. And count of 1 0, count of 2 0. Now for each num in nums, if first we want to check if it's matching with the image. So if num is M1, then count, okay, C1 plus plus, else if num is M2, then C2 plus plus, else before decrementing we're going to check if some of the, if any them is 0. So if C1 is 0, then your M1 is equal to num and C1 equals to 1, and if your C2 is 0, then your M2 equals to num and C2 equals to 1. Otherwise, both your C1 minus minus and C2 minus minus. Now, here there is no it's not a like a given guarantee that majority element exists, right? So that's another thing. So this Boyer-Moore algorithm only works if there is majority element. If there is not, then it can give some random wrong answers. So you have to also verify whether, so if there are majority elements, then they will be M1 and M2. But if there are not, then so you have to basically test whether these are majority elements or not, right? So then you now do is actually so you can maybe do the C1 equals to 0 and C2 equals 0 and find their actual count. So now I equals to 0, simply for each int num in nums, if num equals to M1, then C1 plus plus, if num equals to M2, then your C2 plus plus, and later on you can define a list of list equals to new array list, and if your C1 is greater than nums.length by 3, then you add it. So similarly, if C2 is not C1, you add the element, and similarly if count of 2 not two but three. Then you add this as well, and you return your list. Okay, let's quickly check if this works. Okay, let's submit and see if it works. And it works. Cool, I think this is good.